Hello viewers, I'm Kausalya. Today we are going to solve problem 2 related with ABCD parameters. So here this is the given problem. So in this problem we are going to calculate the ABCD parameters. So when you look at the given circuit diagram, it is clear that these two resistors are connected in parallel. So as a first step, we are finding the equivalent resistance for this combination. So what is the formula when resistors are connected in parallel? That is R1 into R2 divided by R1 plus R2. So here we have resistors named as R2, R3. Therefore here the combination is equivalent resistance is R2 into R3 divided by R2 plus R3. So for our convenient, we are naming this equivalent value of resistance as R dash. So now we are going to replace these two resistors by its equivalent resistance R dash. So here this is your modified circuit diagram. Then we start with writing the basic equations. So this is the basic equation related with ABCD parameters. So as a first step, now we are going to make the value of I2 as 0. When I2 is made 0, we can easily calculate the value of A from this equation and the value of C from the second equation. So here, how to make the value of I2 as 0? Just by short circuiting. Just by open circuiting. So here when you open circuit this terminal, so this terminal is nothing but 1 dash. This is given in the problem. So when you open circuit this terminal, obviously the value of current will be 0. So now when I2 is made 0, then how our first equation get modifies? It get modifies as V1 equal to A V2. Therefore, the value of A is V1 by V2. So now we are going to calculate the value of V1 and V2 here. So how to calculate V1? You see V1 is nothing but I1 into Z. So how to find the equivalent impedance here? You see in this circuit diagram here we have open circuited. So as we all know, the current never flows in the open circuited path. Therefore, this current I1, when it reaches this node, it won't get divided because here there is an open circuit. Therefore, the current I1 flowing through this R1 again flows through this R4. Therefore, the value of V1 is nothing but V1 is equal to I1 into R1 plus R4. So, this is the value of your V1. Now the next thing is we are going to calculate V2 because A is nothing but ratio of V1 by V2. So how to calculate V2 here? So again V2 is nothing but it is the voltage impressed across this resistance R4 because no current flows through this resistor. So V2 is nothing but it is the voltage impressed across this resistance R4. Therefore, V2 is given by, what is the current that flows through this R4? It is I1. So, V2 is nothing but I1 into R4. So, now what happens? The I1 get cancels and finally we have R1 plus R4 divided by R4. So, this is your value of A. Now, we are going to find C. So here when I2 is made 0, then your equation is I1 equal to C into V2. So what is the value of C then? C is nothing but I1 by V2. So for V2 we have just now calculated the expression. So just substitute it here. Again I1 get cancelled and finally we have the value of C as 1 by R4. So now we are going to find the remaining two parameters B and D. So in order to find B and D, we have to make the voltage V2 as 0. You see, this is our basic equation. So now we have calculated the values of A and C. So next we are going to find B and D. In order to find the value of B and D, we have to make the value of V2 as 0. So how voltage can be made 0? It is done by short circuiting. So V2 is the voltage at this terminal. When you short circuit this terminal 1 dash, then V2 will be made 0. So here you see this terminal, okay, 1 dash is short circuited, thereby V2 is made 0. So when V2 is made 0, your first equation becomes V1 equal to minus BI2. Therefore, B is nothing but V1 by minus V1 by I2. So now we are going to calculate the value of V1 and we are going to substitute it here. Okay, we are going to calculate both the terms V1 as well as I2. So here, now this is your V1 and again the same thing, V1 is nothing but I1 into Z. So I1, and how to calculate the value of Z? So you have to find the equivalent resistance of this combination. So you see current entering at this node, it gets divided into 2. Whenever the current gets divided, what does it mean? It means that these two resistors are connected in parallel and that equivalent resistance comes in series with this resistor R1. Because when you simplify this combination, these two resistors are replaced by a single resistor here. Then this resistance and this resistance will come in series, right? We have simplified these two resistors as this single resistor. So once this is done, then these two resistors are connected in series. So V1 is equal to I1 into these two resistors are parallel. So R1 parallel with R4 and that combination is in series with this R1. So this is written as V1 is equal to I1 into R1 plus R dash parallel with R4. So the next step is simplifying. So what is the combination? What is the equivalent value of resistance here? R dash into R4 divided by R dash plus R4. So again when you take LCM, here it becomes R1 R dash plus R1 R4 plus R dash R4 the whole divided by R dash plus R4. So from this equation, again here I am writing it for I1. So I1 is written by just this term moves to this side. So this appears as reciprocal. So this is our expression for I1. Now the next thing is, you see here V1, we have calculated V1. The next step we are going to find I2. So here you see again when you look at this circuit diagram, here this is our I2. So we are going to find this current I2 by using the current division rule. So what do you mean by current division rule? The current division rule is nothing but it is total current into opposite resistance divided by total resistance. So here I2 is given by what is the total current? It is I1. Then what is the resistance which is opposite to I2? It is R4 divided by the total resistance is R dash plus R4. So this is what I had written here. Okay, the total current is I1 and the resistance which is opposite to the current I2 is R4 and divided by here the total resistance is R dash plus R4. So why here we are putting a minus sign? Because the direction of I2 and I1, you see again when you look at this diagram, the direction of the currents are opposite to each other. Therefore, I2 is equal to minus I1 into R4 divided by R dash plus R4. So here, you see we have calculated the value of I1 here. So in the place of I1, just substitute this value. So when you substitute, what happens? You see this term R dash plus R4, they get cancelled. And finally, we end up with I2 is equal to minus V1 into R4 divided by this term, okay, R1 R dash plus R1 R4 plus R dash R4. So this is your expression for I2. So now B is given by minus V1 by I2. So you just keep this V1 as such, minus V1, because you see in I2 we have a minus V1 term. So don't replace V1 with some other terms. So now for I2 just substitute this expression and you see V1 they cancel each other. And finally, we have the value of B as this expression. because here they are in the denominator part. When you move this term to the numerator, they appear as a reciprocal. Now finally we are proceeding with D. So here the value of D is given by I1 by I2. So we have both these expressions, right? You see, for I1, this is our expression for I1 and this is our expression for I2. So now when you substitute these values, you see again the V1 they get cancelled, and the denominator terms of both the numerator and denominator, they cancel each other, and finally here we have R dash plus R4 divided by R4, and there is a minus sign also. And again you see here D is also having a minus sign, or in case if you want to move, you can write it as D is equal to minus of. Okay, anyway it is correct. If you put minus here, then there will be a minus here and these two minus will cancel, and anyway finally the answer will be positive. So finally the value of D is given by R dash plus R4 divided by R4. So that's all. Finally we have calculated the ABCD parameters for this given circuit. If you have any doubt, let me know in the comment section. Thank you.